All right, let's talk about something you've definitely seen, but probably never really thought about, Base64 encoding. It's one of those weird, behind-the-scenes pieces of the internet that's actually kind of fascinating.
Yeah, that stuff. I'm sure you've seen this before, right? If you ever poked around in the source code of a website, or maybe you've seen a super long string of text where a picture was supposed to be, you've run into this. It just looks like a computer sneezed. Total gibberish. So, the big question is, what on earth is this stuff? And more importantly, why is this messy-looking code so important to how the internet actually works? Well, that's the mystery we're going to solve today.
Okay, first things first, let's get one thing straight. This gibberish isn't meant to be a secret. It's not encryption at all. Think of it more like a disguise. Its whole job isn't to hide the data, but to camouflage it so it can travel safely.
So, what's it disguising? Well, Base64 is basically a universal translator. It's a way to take any kind of data, I'm talking a picture, a PDF, an emoji, you name it, and turn it into a simple string of plain old text characters that every computer system in the world can understand.
But why? Why would you ever need to do that? Well, to get that, we have to jump in a time machine and go back to the early days of the internet. See, Base64 was invented to solve a very old problem. You can imagine it like this. The internet's original mailman. He only spoke one very specific, very limited language.
And here's the story. Back in the late 80s, the systems that powered things like email, protocols like SMTP, they were built for just one thing, simple English text. That's it. But of course, right away, people wanted to do more. They wanted to send attachments, use different languages, send all kinds of files. And the old systems, they just freaked out. They'd either flat out reject the data or even worse, corrupt it completely. And this slide just lays out that conflict perfectly, doesn't it? On the left, you've got what the system expected. Plain English. This tiny little set of 128 safe characters, all chopped up into 7-bit pieces. And on the right, you have us, wanting to send images, videos, any language, any file type. The two were just fundamentally incompatible.
I absolutely love this quote from Sergey Bachinin. He calls it contraband, and that's exactly what it is. The data has to be disguised or obfuscated to basically cheat the system, to sneak past these old gatekeepers that weren't built for it. It's a hack, for sure, but a really clever and necessary one.
So, how does this digital smuggling operation actually work? This is where Base64 comes in as the data's clever disguise. It's the brilliant answer to the question, how do you make something as complex as a picture look like a boring old string of text? You know, the process itself is actually pretty elegant. You take any file, let's say an image, the system chops up its binary code into these tiny 6-bit chunks. Then it takes each little chunk and looks it up in a special 64-character alphabet, kind of like a secret decoder ring. It swaps the binary chunk for the text character it matches, and boom, just like that, your complex image file is perfectly camouflaged as a simple, harmless text string that any old system can handle without a problem.
But why just 64 characters? Why so specific?
Well, the key word here is safe. The Base64 alphabet was very carefully chosen. It only includes characters that won't cause any trouble, your standard A to Z, numbers, and a couple of symbols. It avoids all the unsafe characters, things like control characters or symbols that have special meanings in code, because those could completely break the systems it's trying to talk to. Okay, so that's the history. But this isn't just some dusty old relic of the past. Base64 is still everywhere today. And that clever disguise, well, it comes at a price. It's the cost we all still pay for supporting the internet's history. And that price can be boiled down to one pretty big number, 33%. Because that translation from compact binary data into text isn't a one-to-one swap. It makes the data about a third larger on average. That is a significant overhead. And this chart just makes it super clear. Look at this. If you start with a 100 kilobyte file, once you run it through Base64, it's going to be about 133 kilobytes. You're literally adding a third of the original size just for the sake of compatibility. So if it's kind of clunky and adds all this extra size, why is it still so common? Well, you use it every single day. When an image is embedded directly into a web page's code instead of being a separate file, that's Base64. It's used for sending login details, for stuffing binary data inside text files like JSON. And yeah, it's still out there making sure our emails can get through ancient legacy servers. Which brings us to a final, pretty interesting thought. At its heart, Base64 is an incredibly successful hack that solved a 40-year-old problem. It worked, but its legacy, that 33% size penalty, is a cost we're all still paying today. And it really makes you wonder, doesn't it? What are the clever hacks we're building right now that are going to become the constraints, the baggage, for the internet of tomorrow?